Hi folks, so this is question 3. So we have to prove that root 2 is not a rational number. So we're going to end up proving by contradiction here. So I'm going to let root 2 be equal to, so this is a general proof, you just kind of need to learn how to do it. So we'll let root 2 be a over b, so where a and b are elements of the integer. So by definition, that's to be a rational number, that's what it has to be. You have to be able to represent it as a fraction. So if I square both sides there, I have an equation now, I can do whatever I want to both sides. So 2 is equal to a squared over b squared. Then if I bring over the b squared, we get 2b squared is equal to a squared. Now from this I know that a has to be even. And the reason it has to be even is because if you put any number in, we know that b is an integer, so any number in instead of b there, whether it be a positive number or a negative number, if you square that, it has to give you a positive. And then if you times that by 2, then it has to give you an even number. So times it by 2 has to give an even number. So therefore we know that a squared is going to be even. And therefore a has to be even as well. So we'll let a be equal to 2k now. So k is just some integer as well. So we've shown that a is even. So I can put back in 2k in instead of a. So 2b squared is equal to 2k to b squared. So that'll be 4k squared is equal to 2b squared. So divide by 2, we get b squared is equal to 2k squared. Right, so we're going back to kind of what we had before then. So b squared is equal to 2k squared. So if you put any number in instead of k there, any number integer, then and square it and then times it by 2, it has to give you an even number. And because any even square number, any even number squared will give you an even number. So b ultimately has to be even then. So b is even as well. And that is the basis for our proof then. So we know that a and b are even. So then this contradicts the fact that root 2 is an a over, that a over b is in its simplest terms. Therefore root 2 is not going to be equal to an integer over another integer. So therefore you've contradicted the statement. So that's the proof, and that's all you need to do for part A. Right, so part B then, so this is to do with logs, and they actually give you a hint here that you need to use this change of base formula. So really we want to take everything here and we want to change it into the same base, and then we can just use more rules of logs then. So the obvious one is to change everything, because you have a 9, you have a 27 and you have an 81. So even if by looking at those 3 numbers, the obvious number they have in common is 3. They're all 3 to the power something. So what you have to do is you have to change everything into log to base 3. So the first one is anyway, you don't need to do anything with that. Plus, okay, and then you have to use this rule here. So log b to base a is the same as log b to base c over log a to base c. So I'm going to change everything into, you can change into whatever, the rule means you can change into whatever base you want, but 3 is the obvious one here. So log so it's going to be base 3, and it'll be t then on top, and on the bottom is just going to be log 3 and 3 plus log 3 and t, or log t to base 3 over log 3 to base 3 again. Sorry, that's going to be 27 actually. Yeah. Sorry, and that's going to be 9. I'm getting ahead of myself. Then the last one will be log t to base 3 over log 81 to base 3 is equal to 10 altogether. So what happens here on the bottom, so log, you can do it in the calculator if you want all the bottom parts because you just have numbers in them, but this here is basically 3 to some power is equal to 9, so it has to just obviously be a 2. So we get 2 on the bottom here, and then we get all these log t to base 3's on top. This one will be 3 to the power of 3 is 27, so 3 on the bottom. And then this one is 4 equals 10. So yeah, so we need to basically get rid of all the bottom. So if you multiply, if you just multiply everything by 12, it might be a simpler, quicker way of doing this, but just multiply everything by 12, so you get plus 6 log t to base 3 plus 4 log t to base 3 plus 3 log t to base 3 is equal to, and then we have to multiply the right hand side by 12 as well, so 120. So I can add up all, because they're all just log t to base 3's, and just add them all together. So 12 and 6 is 18, and 4 is 22, and 3 is 25. So we get 25 log t to base 3. So I end up getting that equals 120. Therefore, if I bring over to 25, I just get log t to base 3 is equal to 120 over 25. And then, where did I want the answer? So give your answer in the form 3 to the power of r, so where r is some element of q, so r can be a fraction. So therefore 3 to the power of 120 over 25, we can simplify that down into 24 over 5 is equal to t. So 3 to the power of that has to be equal to that. So therefore 24 over 5 is our answer, or well, 3 to the power of 24 over 5 is the answer. Right, so the last part then, right, so very unusual for a part C of a question, so you have to explain now what log m to base 6 means where m is a positive real number. So you just have to do your best to explain what this means. So it's just so there might be a better way of explaining it, but so if you raise 6 to some power, so m in this case, then actually no, m is not the power, obviously. If you raise 6 to some power, then log m to base 6 then log m to base 6 is the power it must be raised to give you m, or to get m. Alright, probably not the best statement in the world. Okay, there's probably more concise way of phrasing that. So if you raise 6 to some power, then this is the power it must be raised to give you m. Alright, it's a strange part for part C. Right, so m is a real number and m is greater than 6. What information does this give you about the value of log m to base 6? Right, so let's just take it that if it was 6, so if it was, it's not, so m is greater than 6. So if it was 6, these are awkward questions, they're not really straightforward. So if it was 6, well then log 6 to base 6 is equal to 1. Okay, so we know m is greater than 6, therefore the power that 6 is being raised to so i.e. log m to base 6 is greater than 1. Okay, so if it was 6, well then it would be equal to 1. So therefore, because it's greater than 6, because m is greater than 6, whatever you put in there for, so if you put 7, 8, 9, 10, whatever, the whole thing will end up being greater than 1, has to be greater than 1. So that's as much as I can take from that. So that's all for that question.